All right, hello class. Welcome to lesson 2.1, part 1. We're going to be this lesson is about parallel lines. So this new unit is about lines and proving theorems about lines and that sort of topic. So we're going to actually introduce parallel lines. We're going to talk about theorems that involve parallel lines and what we call transversals. And there will be another part to this. So the essential question are what angle relationships are created when parallel lines are intersected by a transversal. And so we want to determine the measures of angles formed when parallel lines are intersected by what we call a transversal. So the vocab includes alternate exterior angles, interior angles, corresponding angles, same side interior, and transversal. So we're going to talk about identifying angle pairs from when you have a parallel line cut by what we call a transversal. So in this example, you see that we have two parallel lines, N and M, and we have a line that crosses them, the red line, which we call the transversal, and then we call that the transversal T example. So we can see that the blinking line is called a transversal. A transversal is a line that passes through 2 points in the same plane at 2 distinct points. In this case, it's crossing the 2 points which are in the lines N and M. So the symbol for parallel lines is given by the arrow. And if you have different sets of parallel lines, then you can use multiple arrows for parallel. And when you write this out, as line M, and then the double pipe, basically two vertical lines, and line N. So this means that line M is parallel to line N. That's the diagram symbol for parallel. So that literally means is parallel to. So let's talk about exterior angles. So if we look at in the previous here, 1, 2, 7, 8 are what we refer to as exterior angles. And that's because they're on the exterior or outside of the diagram. Whereas 3, 4, 5, and 6 are what we call interior angles. They're inside of that diagram. I liken it to like a sandwich. So if you think about the two pieces of bread, think of them as parallel lines, or just lines that are stacked on top of each other. Now we know that, and then we can think of the toothpick. If we have a toothpick that goes through that sandwich, we can think of it as the transversal. Now, if you're talking about inside the sandwich, well, that's the interior, right? The interior is the inside of the sandwich, and the outside is the exterior of the sandwich. And so you can think of this in terms of exterior and interior angles. All right, so now we're going to talk about alternate angles, exterior and interior. So angle 1 and angle 8 are alternate exterior. Angle 2 and angle 7 are also alternate exterior. Notice that they're on both sides of the toothpick or the transversal. And then when you think about angle 3 and angle 6, they're inside the sandwich in our analogy, and they're on opposite sides of the transversal. And 5 and 4, so that should say 5. So 5 and 4 are on opposite sides of the transversal, and they're inside as well, and so they're alternate interior as well. For alternate means on opposite sides of the transversal. So now let's talk about the same side. If they're on the same side of the transversal, we call them same side angles, right? So angle 3 and angle 5 are same side interior angles because they're on the inside. Angle 4 and angle 6 are same side interior angles as well. And then let's talk about corresponding angles. So corresponding angles are also tend to be on the same side of the transversal, but the difference is that they are actually literally the same angle. So if like the same measure. So if you think about it, angle 1 and angle 5 are in blue here. They're on the same side of the transversal, but they're actually the same type of angle. So if you look at here, if you look at this and this, that's the same type of angle as this and this. So you can see that they open up in the same way, and they're in the same relative positions. So we call them corresponding. Similarly for 3 and 7, those are given in red, they open up in the same manner, and so we call them corresponding. Okay, so remember, this terminology applies not only for parallel lines but for other lines in general. So these lines N and M need not be parallel for you to use these definitions. Angle 2 and angle 6 are corresponding in green. Angle 4 and angle 8 are corresponding in bold. So like we said, corresponding means they're occupied the same relative position. So in this case, angle 1 and angle 2, let's talk about a linear pair. Angle 1 and angle 2 are what we call a linear pair, because remember, a linear pair is when you have at least two lines crossing each other, and then you have two angles that are next to each other that end up being supplementary, and we call those a linear pair. So in this top example, angle 1 and angle 2 are a linear pair. Similarly, angle 3 and angle 4 are a linear pair, and angle 5 and angle 6, angle 7 and angle 8, angle 5, angle 7, all of these combinations where you have a line crossing, two lines crossing, and then the angles are next to each other, those are all linear pairs. And then remember, a vertical angle is when you have two lines crossing and instead of looking at the angles next to each other, you're actually looking at the angles across from each other. So in this case, angle 1 and angle 2, if you look at this diagram I just drew, are vertical angles. But if you look at the diagram, the diagram that is not drawn but is actually, an actual diagram, angle 1 and angle 4 are opposite of each other and they're vertical. Angle 2 and angle 3 are vertical, they're opposite. 5 and 8, and 7 and 6. So let's look at an example. There is a section of the map which shows two roadways being intersected by a railroad track. Identify the pairs of angles formed. So we're going to go ahead and list out the alternate exterior, alternate interior, the corresponding angles, and so on, and same side interior angles. So we're going to actually draw this out. So for the alternate exterior angles, keep in mind that the transversal here is given by the railroad. And in the two roads are the actual, think about in our analogy, are the actual pieces of bread in the sandwich, okay? So if you can imagine that, well then these two roads are not parallel to each other, but they're still, they still work for our analogy. So for the alternate exterior angles, we know that outside of the bread, outside of the sandwich, the exterior angles are 1, 2, 7, and 8. And then the ones that are on opposite sides are 1 and 7. So we can say angle 1 and angle 7 are alternate exterior. In addition, we can say angle 2 and angle... Oh, I meant to say angle 1 and angle 8. I apologize for that. And then for the next one, angle 2 and angle 7, they're on opposite sides as well. So we can say angle 2 and angle 7. So for the alternate interiors, what we have here, the ones that are inside are 3, 4, 5, and 6. But the ones that are opposite sides are 3 and 6. And then we have 4 and 5. So those are my alternate interiors. And so now we want to look at the corresponding. So for corresponding, remember that they have to occupy the same types of positions. So in this case, if we look at, if we look at angle 1, the angle that has the same kind of position as angle 1 is angle 5. You can see they have the same kind of position. They're both above their respective lines, like above the pieces of bread, the blue lines here. And they're also both to the left of the transversal. And so therefore they have the same kind of position. And so we call those corresponding. So that would be angle 1 and angle 5. In addition, Another one would be angle 3 and angle 7. Angle 3 and angle 7, they're both below the blue line and they're both to the left of the red line. So we can say angle 3 and angle 7. There are a bunch of different answers here. You could also say angle 2 and angle 6. You could say angle 8 and angle 4. And those would be examples of corresponding angles. And now for the same side interior, the same side interior, they're inside and they're also on the same side of the transversal. So in that case, that would be 3 and 5. So angle 3 and angle 5. Then you have 4 and 6. They're on the same side. So angle 4, angle 6. All right, so now we're going to look at some postulates as they relate to the pairs of angles that we looked at, the types of angle pairs. So let's look at the same side interior angles first. Postulate for this states that if you have a transversal that intersects two parallel lines, and notice they have to be parallel, and you can see in the diagram, they're given by these arrows, and that indicates that they're parallel. So if you have two parallel lines cut by a transversal, then the same side interior angles have to be supplementary. Remember that supplementary means they add up to 180. In this case, the same side interior angles are, well, you have angle 3 and angle 5, they're on the same side, and then you have angle 4 and angle 6. And so angle 3 and 5 are supplementary, so they add up to 180. Same thing for 4 and 6. And so that's the postulate. So for example, if we had something like this, well, we have these two lines are parallel. And so in this case, the transversal, we'll label that T is this line right here, this line in red. And so if we have angle 1 there and then angle 2 here, for example, well then angle 1 and angle 2 and in this diagram are same side interior angles. And so they have to be supplementary. And then therefore, if you add them together, they should equal 180. But if you knew that this was a 35-degree angle, well then you know that this right here has to be a 155-degree angle because 155 plus 35 is 180. All right, so now we're looking at the alternate interiors theorem, angle theorem. If a transversal intersects two parallel lines, just like it was earlier, then alternate interior angles are congruent. And so here we have our transversal cutting through, and our alternate interior angles include angle 3 and angle 6. That means that they're congruent, they're the same. And then angle 4 and angle 5 are alternate interior, and so they're also congruent, or they have the same measure. Remember that if they're congruent, this means that they have the same measure. So this means that angle 3, the measure of angle 3 is equal to the measure of angle 6. And this is by the definition of congruent angles. And we can write similarly for these two as well, for 4 and 5. All right, so the alternate interior angles theorem. So another example of how this looks like. So let's say we have a diagram that looks like this time. Well, then those are my parallel lines, and then here is my transversal that cuts through those parallel lines. So let's say we had angle 1 there, and we had angle 2 here. And so angle 1 and angle 2 are alternate interior angles in this example. And so if we know that this is 45 degrees, well then because they're alternate interior, that means that this is also 45 degrees. And so measure of angle 1 is the same thing as measure of angle 2, which is 45. All right, so now let's look at corresponding angles. So again, we have two parallel lines cut by a transversal T. And so it says that corresponding angles are congruent. So for example, angle 1 and angle 5 are congruent. And so we can say, because they occupy the same type of position, they're both above their lines and to the left of the transversal. And so those are the same angle. So they're congruent to each other. So this means that measure of angle 1 is equal to the measure of angle 5 by the definition of congruent angles. Similarly for 4, this should not say 6, so make that correction right there. It should say 4 and 8. 4 and 8 are corresponding angles in this example, and so they have to be equal to each other. So not 4 and 6. All right, so let's look at an example. So let's say we have a setup that looks like this. Well, we have our two parallel lines here. We have our transversal cutting in this direction. And so this is angle 1. And so we're going to look at, well, let's suppose that this is angle 2. Well, in that case, if that's angle 2 and angle 1, well, those are corresponding angles. Notice that they're both below. They're both to the left of the blue line, and they're both also above the red line, and so therefore they occupy the same type of position. And so we can say that they're corresponding, and by the corresponding angle theorem, that means that they have to be identical, they have to be congruent, and so that means the measures are both 50 degrees. All right, so for the alternate exterior angles theorem, again, two parallel lines cut by a transversal. Now we're looking at the exterior angles alternate. So for example, angle 1 and angle 8, or angle 2 and angle 7. So those are alternate exterior angles, and they have to be equal to each other. So angle 1 has to be equal to angle 8, the measure of angle 1, and then angle 2 has to be equal to angle 7. So this does not mean that angle 1 equals angle 2 equals angle 1. That's not true, okay? What it means is that only the measure of angle 2 has to be equal to the measure of angle 7, okay? Similarly, measure of angle 1 has to equal measure of angle 8. So let's say we have this example. And so let's say we have 1 and 2. Well, then those are alternate exterior angles. Let's say we knew that 1 is 32 degrees. And so this means by the alternate exterior angles theorem that this also has to be 32 degrees. They have to be congruent, and therefore their measures are the same. All right, so let's look at the last example for this part, for this part 1 video. So let's say we have, something that resembles a barn, and we're looking at the trim of that barn. So there are a bunch of lines there. And it mentions that AC is parallel to EG. So if we're talking about AC here, this is parallel to EG, which kind of makes sense. And then we know that JA is parallel to HB. And so we'll indicate that with a double arrow. So I'll use another color here. So we know that those are parallel, and we'll indicate that with a double arrow. Notice that I'm using a double arrow and not a single arrow, because it's showing that the ones with the double arrows are parallel, the ones with the single arrows are parallel as well. And then it also says that JC is congruent to KG. So we're looking at those two lines. And so we'll say that they're parallel to each other, so I use a triple arrow. Okay, so let's go ahead and draw this diagram out so we can get a better look at it. So there's the diagram version of that picture that you see there. And so we're going to say, okay, we have those parallel, and then like we said earlier, that those are parallel. So let's focus on that diagram. So remember that we're trying to find certain angles in the problem. So what we're going to do is I'm going to focus on JA and HB, and I'm going to focus on CA, the line, so the blue and the green, and I'm going to erase everything else. And so that's what we have so far. If we focus on that, well, we can see that it's just two parallel lines cut by a transversal. And you can also see that 61 and 1 are same side interior angles. And because they're same side interior angles, they have to add up to 180 by the same side interior angles postulate. And so we said, okay, well, they have to be supplementary, so they add up to 180. And so if I subtract 180 from 68 from 180, I get 112. So I know that this has to be an 112 degree angle. All right, so we know angle 1 is 112. Going back to our original diagram, now let's focus on two different sets of lines. Let's focus on EG and BC, or CA, and then the green line JA, and erase everything else. So now if we erase everything else, we can see, well, that's two parallel lines cut by a transversal, which is given in green. And you can also see that 68 degrees and angle 2 are actually corresponding angles. And so because they're corresponding angles, by the corresponding angle postulate, they have to actually be equal. So we know that angle 2 is also going to be 68 degrees. And so we'll go ahead and label that. And so we found angle 2 is 68 degrees. All right, and in this case, okay, so it looks like in this case, we found another angle, angle 2. Now we found angle 1 here, and so we found this guy, and we want to figure out angle 3. So we found a little bit of extra information, but how would we figure out angle 3? Well, so angle 3, if you were to think of these as your parallel lines, and then you can think of, and I'll use another color here, you can think of this as your transversal. Well, now we know that angle 2 is actually equal to 68 degrees. And so you can see that angle 2 and angle 3 are actually corresponding angles because they're both below the black line and they're both to the left of the red line. And so angle 3 has to be 68 degrees as well by the corresponding angles postulate. And so we can say that this is also equal to angle 3, which is 68 degrees. All right, that's it for the part 1 video, guys. We're going to go ahead and continue the other video, the other part 2 for 2.1 in another video. Take care, guys. I hope you learned something from this video, and I'll see you in the next one.